from an engineering perspective, technology, is always fascinating. It's always something that I've could and felt excited about. But the reality of the world that we live in is also that, just because the technology is cool doesn't mean it's going to have any sort of impact or any sort of future if there is no economic outcome from it at the end of the day. So I felt strongly that technology and financial outcomes needed to be aligned for anything to scale, to have impact, and to have longevity.
As I was reading up on Xendee before this, I had not really conceived of such a system, but when I saw it, it made perfect sense that this has to be there. For someone who's unfamiliar, can you describe what does Xendee do and what sorts of problems does it aim to solve?
So we're a software company, and we develop and offer software, and we do it as a service. So web-based browser subscription software. And our whole purpose is to really take the pain out of selling, designing, and operating complex distributed energy systems for the commercial and industrial markets.
I was about a year ago at UL Solutions' new EV lab out in the Chicago area, and they were having some discussions around just how they had to talk to the utilities people and the grid people to actually get enough power to their building and that sort of infrastructure. And that was all kind of new to me. I had never thought about the need for that sort of infra for a commercial installation instead of just like houses. Can you talk about what is a distributed energy resource? I know that has come up a couple times. And then B, what sort of problems and what's kind of the world of utilities and power at this point?
Sure. So distributed energy resource is a technology that can generate or store energy. So an example most people will be familiar with is solar panels. So solar PV is a distributed energy resource. Batteries, that's a distributed energy resource as well from a storage perspective. Fuel cells, generators, wind turbines. So anything that can produce energy on site or store energy on site would be considered a distributed energy resource. And when I say energy, it's both electric and thermal. So the ability to produce and store electricity, the ability to produce and store thermal as well.
We talk a lot about power generation being a field of tech and power storage, like battery technology being really important, but the interconnect of the two is such kind of, in my mind, a bit of a hidden field that has so much opportunity for us to advance as a society. There's just so much that could be done. Your LinkedIn tagline says, disrupting the design and operation of EV infrastructure and net zero distributed energy systems. Can you break that down a little bit? Where's the disruption here, and what's kind of status quo, and then how do you come in as Xendee to help kind of disrupt that situation?
The status quo has been internal tools and spreadsheets. So a very cobbled together approach to proposing these systems, feasibility, planning, design, and operations. Every single one of these steps typically is disconnected from the other step. And when you're talking about a single technology like a solar panel or maybe just a battery by itself, you can probably get away with that. You can do hand calculations or use a spreadsheet and get good enough. But once you start building out solutions and systems that are not single technology, but multiple technology, the disconnect is that spreadsheet output and the results aren't going to match whatever software is being used to do the next step, because that piece of software is probably using fundamentally different math, different algorithms, different methods than maybe what was programmed in Visual Basic in a spreadsheet. And then the detailed design, probably a whole different, again, software stack for that. And again, there's no connection to the feasibility study, for example. So again, another disconnect. And then operations, a controller comes in and programs rules in it that aren't necessarily aware of what the assumptions were in the design phase. And when you're talking about complex systems, whenever you have this many disconnects, that's what drives fear into the heart and minds of investors. With a single technology, you can build a good enough model to understand the benefits and the outcomes that you're projecting to then put money at risk behind the project. But when you start bringing a diversity of distributed energy resources, just 3 or 4, like I mentioned, a typical system, nothing super complex from a individual technology perspective. I always use the scoop of ice cream example. You go to an ice cream store, they put all these flavors in front of you, they all look great, but I'm not going to get every scoop, so I got to kind of constrain myself to what I'm really going to look for. But you get a sample, right? They give you a little spoon, you see if you like it or not. You want to go buy a car, you take it for a test drive. They call it kicking the tires before you commit to it. But when it comes to renewable energy systems, in these complicated systems, we didn't see this trialability. You had to just trust and hope, and then they would go build it, and then you just had to hope that the benefits will materialize. And that's a pretty big hurdle to overcome with the dollar numbers that are at stake. So we felt an important part of what we can enable through this platform approach is give people a virtual test drive as close as possible to what they can expect when they actually physically build and operate the system. But to do that, we had to solve the operations side and we had to solve the design side and give the ability for the end user, the stakeholders, to be able to see and have confidence in what the outcomes could be. So we enable a test drive environment for these distributed energy and renewable energy systems. And once you're happy with the test drive, you can have a high level of confidence in the reliable outcomes of these systems. So we felt that was an important roadblock to address.
Yeah, if you're going to invest in building something, it's good to know that all your boxes are checked and you're not trusting this handoff system of spreadsheets to get things done. I always feel bad for people who are really good at Excel pivot tables, as someone who used to be really good at Excel pivot tables. Where does the data come from?
So that's the thing. When you're dealing with complex systems, there's just a lot of data, and it can become overwhelming. So we looked at how we can take some of that off of the shoulders of the project developers and the stakeholders. So we built in a lot of automation where once you punch in an address, the software automatically does a scan to see if it's in like a low-income community or an energy community to see what additional benefits might be available to you. It automatically goes and grabs historical 30-year satellite data for temperature, wind speeds, solar radiance at that location. It automatically goes and grabs the marginal carbon emissions from the grid at that location. So it can show you how this system can help decarbonize further than what if you were just to purchase straight off the grid. And it also goes and grabs automatically all the utilities servicing the area and all the tariffs available as well, and what are the most popular tariffs in that region. So all that gets done automatically in the background by just punching in an address. Most of that is in the United States and some of it is in Europe, that level of automation. So in some of the developing parts of the world, there still is a need to manually provide some of that information because there's just a data gap.
Is this all API driven then? Like
it's all API driven.
Calling databases, that sort of thing.
All commercial data, all commercial service providers. So we pay commercial service providers that their business is maintaining a real-time database of quality information around these particular inputs, and then we pull it in.
Okay.
But you can override any of them. So
sure.
You can override any of them, but that, you just put in the address and boom, all that's done.
I understand you also get like a one-line diagram. Can you describe what that is, why it's useful, and maybe what you'd be looking for in that diagram?
Absolutely. So one of the gaps we saw out there, even when, I mentioned like people built internal tools like spreadsheets or they use some existing software that might be out there. When we looked, at least I was shocked that there's no concept of a cable or transformer in any of these approaches. They would have to go into a complete separate power system modeling and simulation platform to get that level of rigor in the design, and that's usually very costly and quite time consuming as well. So we felt that it was important for the algorithm as it's generating a solution to also consider the constraints of the underlying infrastructure. And to be able to do that, we felt that the electrical one-line diagram and a physics model would be important to implement in parallel with the ability to size the technologies and the control strategy. It's important because when you're starting to look at large complex energy systems, your cabling is a critical piece of technology to ensure that the electricity is going to get from where it's being generated to where it's being consumed in a safe and reliable manner. These have physical limitations. I mean, if you exceed their capacity, they melt, they cause fires, there's short circuits that can occur, all sorts of bad things happen. So understanding the capacity of these and how much you can actually put into a system, both in a grid-connected environment and then when you have to island, where now maybe your infrastructure has to even carry more of the burden than perhaps you were relying on the utility connection to provide to you. And then transformers as well. And these have efficiencies too, so there's losses in the system from these. And if the losses are too big, you start getting voltage drops, you start getting all sorts of power quality issues, maintenance, now the installation wear is just a lot faster. And knowing what you have from a capacity perspective and what you might need to upgrade, or if you want to defer upgrades, what you need to be able to do to achieve the objective that you need at the end of the day in a safe and reliable manner, we felt was critical. And we didn't see anything out there that actually considered the underlying distribution system. And I just didn't know how people could make a decision on building an energy system, let's say an electrical focused microgrid, without any consideration for cables and transformers. So for us, one of the enabling capabilities we bring to stakeholders, and also I think it drives more confidence into the operational decisions and the financial performance of the system, is we generate that electrical power system model, which is typically reflected as a one-line diagram or a single-line diagram, because it takes the 3 or 4 wires for the different phases and collapses them into a single line, which is why we call it a single-line diagram, just to keep the diagram simple and not overly complicated. But that shows that the underlying distribution system and its limitations have been considered as part of the technical design and the operational strategy, because it then gives the algorithm the opportunity to not only size the technologies properly with regard to the losses of the distribution system as well, but also what locations are the optimal locations to install those technologies, so that you don't end up putting a battery behind a skinny wire, and now you got this big battery that can't necessarily contribute as much as it could if it had additional cabling or more capacity within the underlying distribution system that it had. But that goes for all the different distributed technologies out there. So we have that concept of the physics, we run that physics simulation, and we make it available in an open standard format to then be seamlessly taken into the more sophisticated power system simulation platforms that have been out there for 30, 40 years and the utilities use. But that's the benefit that it brings. It brings the full design rigor up to a 30% design in a very short period of time. So when we say we reduce soft costs by 90%, that's not us saying it. That's our customers coming to us and saying, you saved us 90% time in what we were normally doing, using fairly sophisticated tools, that they thought they had at that time.
That's significant. Yeah, but I suppose if you're installing like a level 3 charging system, you don't want any surprises. Like that's the last thing you want.
That's the thing. I mean, maybe with like small solar generator setups, people could get away with just having a dollar number for balance the system and just throwing it together. But when you got trucks coming in with 700 1 megawatt hour battery packs, and now you got to charge that in a very short period of time, got a lot of electricity that's going to be going in. These things all of a sudden become very, very important. And to your point, you do not want a surprise, because that surprise usually isn't just financial. It could very well involve human life and safety as well.
Can we run a thought experiment? So let's say I'm wanting to add EV charging infrastructure. I have 10-ish like mid-sized trucks that are going in and out. I want to make it electric, and I want to install a charging system at my site. Maybe a couple employees can charge too while they're at work. Where would I get started? What would I need to think about?
So there's three things really that you need to think about. One is kind of what you feel the number of vehicles you need to have charged and when you think they're going to need to get charged. So kind of that charging pattern, if you want to think around that. The commercial folks call it a fleet schedule, but I think for an office setting, it would be really when people show up for work and when they maybe go to lunch and maybe when they come back. So when are they going to be plugging these things in, and when do they need to leave by? So you can take some guesses around that. That's one thing to think about. The other is what your goal is. Do you want to decarbonize your office building and the charging system? Do you want it to be purely economic, where you want to save money and maybe even make some money? Or do you need some resilience, where maybe in the past people haven't been coming to the office because there was power safety shutoffs, the air conditioning wasn't running, and it was just too hot for anybody to work in the office anyway? Or some combination of these where you need the resilience to ensure occupant comfort. You need to provide that EV charging solution and do it in a way that makes you money potentially, not lose money. And perhaps the cost savings that you might be able to achieve over the next few years for your tenants and for your office, and the ability to perhaps decarbonize that building as much as possible. So I would look at the objective. Is it decarbonization, economic, or resilience, or whatever combination, or how you want to weigh it? So that's another thing to consider. And then the other is just what technologies you're interested in. So clearly, there's level 1, level 2, level 3 chargers, but are you open to solar panels? Are you open to batteries? Maybe you have a boiler that provides hot water. Do you want to decarbonize that perhaps and move to an electric boiler? These are some of the decision-making points. And then you just put those hopes and expectations into the software and give it the goal or a set of goals or objectives, and then it'll generate the solution for you. It'll come back and say, Daniel, you should have 4 level 1 chargers and 1 level 3 charger. And this is why. So, the operational rationale behind the decision. And you told me you have this much space available for solar panels and maybe this much for carport solar. This is what I recommend. This is the algorithm recommending what size and mix. And it might come back and say, the carport I didn't recommend because it wouldn't meet your financial goals. You wanted a payback period, or you want a certain economic outcome. That would just lengthen that the time to those results. But it could come back and say, this is the size battery you need, and this is how the battery, the charger, and the solar panel are all going to work together. And by the way, you said that you'd be open to maybe looking at that boiler. So it'll give you an option for perhaps a combined heat and power system that can provide both the thermal and electricity with a very small footprint generator. Or it might give you the opportunity, if you ask, for perhaps switching it out to a electric heater. So, and shows you the value streams that it was able to take advantage of. So whether there's grants, whether there's incentives, tax rebates, all of these are also brought in. And then how you want to finance it. Are you going to buy it all up front? Are you going to take a loan? What percentage of it is going to be the loan? So all those nuances around the financial flexibilities that you're considering can also be captured, and then the output will reflect that. So if you say, I want a cash purchase, it might give you a different mix and set of technologies than if you say, I'm going to take a loan out.
So let's say I land in a situation where I want to, maybe like a megawatt of power for a charging station and other electrical infra. How do I know if the grid is actually going to be able to provide this to me? Do I got to like pick up the phone and call my local utility engineer?
Yeah, with some utilities, you actually, as a customer, you have to call and say, usually on your tariff, it'll say what your limit is. So if you're on a commercial tariff, it usually kind of has a concept of what what your limit is, and if you need to go to the next level, you will have to call them. So the first place to look at is your tariff. We can capture that in our model as well, what the utility constraints are from being able to import and export electricity, and the system considers that so that it's not pulling more juice from the utility circuit than the utility is able to provide, and at the same time, what you can sell back to the grid is also captured in the way that the utility would expect it. So more often than not, though, it's probably safe to call the utility and find out what the capacity is for the connection that you have with them.
Yeah, because we're easily talking neighborhoods or multiple neighborhoods worth of power, or skyscrapers worth of power into like a very small physical footprint.
Yeah. Especially when you're talking about the commercial sector, right? Because passenger vehicles, they still, 350 kilowatt chargers, but imagine you have 10 trucks coming in, and each one has like an 800 megawatt hour battery pack on them. I mean, to your point, now you're talking, Empire State Building kind of energy needed at that one location. And how do you make that happen? Because the schedule has to run. The fleet has its schedules, deliveries have to happen, and the route has to be completed. So the operational schedule needs to be honored, and that means you now have a lot of energy that has to just, be available. And from the utility perspective, they want managed load growth. I mean, that's where I think the future lies, is in a hybrid environment where you have the centralized power system from the utilities, and then you have the microgrids on site that shape the load to the pattern that the utility cares about, and then being able to offer the utility the managed load growth while serving the EV charging infrastructure and making it profitable too. Because when the trucks aren't in, there's opportunities for selling back to the grid. There might be opportunities for demand response events that can then generate additional ancillary revenue opportunities. And then there's also ancillary services, participating in frequency regulation or standby spinning reserves. So there's a lot of revenue streams that open up when you have your own energy infrastructure on site.
That makes sense. Diversification, but also it's business critical, so you got to get it right.
Yeah, it's business critical in that, you have your levelized cost of energy, and you know what that's going to look like for the lifetime of the project versus it fluctuating every year or two based on, the business objectives of other companies. So you're really bringing stability into your business case, and that intraday pricing variability that I think we were talking about earlier, where you have this huge fluctuation in the cost of electricity. Now you can leverage that to your benefit by owning your own power production infrastructure on site.
Keynote speakers and live sessions for EE Power Day are brought to you by Mouser Electronics. As your design fulfillment distributor, Mouser is your authorized source for millions of components from over 1,200 leading brands. Come discover, design, develop. So if I have my proposal, I kind of know what I want to do and why I want to do it, and I have the justification. Does Xendee give me like reporting that I can then go to my management chain and investors and start to get that sort of stuff?
Yeah, we have very elegant reporting with all the standard financial reports, a robust and rigorous technical report as well. so that the financial decision maker understands and appreciates the level of rigor that went behind the projections that they're looking at, and the technical team has confidence that the system can actually perform and deliver on those promises being made. So it's a elegant, multifaceted report that covers at a high level what the opportunity looks like, what the technology mix looks like, and then gets into the weeds down to the one-line diagram. I consider the one-line diagram really getting into the weeds, because now you're getting into some of the nuances around these various technologies, from just a resistance and reactance of cables to the kVA rating on transformers, things that power engineers really like. And a financial decision maker will appreciate that that level of technical rigor has gone into the plan, and that the numbers, there's confidence behind the numbers. And to deliver that confidence, I believe you have to have that technical rigor. And we saw that technical rigor really missing, or when it was done, it took a very long time and it was very costly. And you could do that in the past, because a lot of projects were really heavily dependent on grants. So the cost and the risk of the performance of these systems were really being shouldered by the taxpayer. But when you're talking about where you need to be, it needs to be scalability with the ability to deliver impact nationally, globally, and doing so with institutional investors. And institutional investors are going to want that financial due diligence to pass all of the areas that they care about, particularly on the technical side, because of the inherent complexity of these systems.
So I have my problem. I've built out a plan. I've gotten buy-in from everybody and built the thing. What do I do next? What does like day-to-day operation look like? Is it like weekly reporting, like checking our goals? Kind of what does that life look like for somebody?
So once the system is built, then we offer our Operate software solution, which essentially gives better logic every 5 minutes to the system based on its forecast of what the next 48 hours are going to look like. And it changes its opinion on what the next 48 hours are going to look like every 5 minutes. So it's a rolling forecast that it does. And then it comes back and tells the central site controller or the technologies what they should do to achieve the outcome that they want. It's fairly automated, so you can have human in the loop, and some people prefer to have a human in the loop to make that final control decision, but it's not required. The systems can run autonomously. And then from a reporting perspective, there's dashboards, and there's a lot of metrics that we provide that customers can create their own bespoke dashboards and reports based on. But it's literally a dashboard that's updated every 5 minutes. From a savings perspective, let's say if there's generators on site, fuel consumption, demand charges, all of the financials that are important to track, and they will fluctuate, hour by hour, every 15 minutes or so forth. But what the goal was, what it's trying to accomplish, and what it would have been without the system. So to come up with the savings. So it's always running a base case of what it would be, and then it's also showing you what it is and what it was able to capture from a revenue or savings perspective for you. And what we've seen, Daniel, is when we've done several commercial pilots now with Operate, is we're delivering 30% more profits and 65% better savings than their traditional logic and operational strategy.
That is very significant. It makes sense that using real-time data to build near real-time data to build your own control logic, or provide an operator with the right information that they need to make the right decision, makes a ton of sense for cost savings.
Yeah,
absolutely.
And it's all the same optimization engine, and it's all it knows what's already installed, and knows what the performance constraints of these systems are, and it also knows what the objective is. So it knows what job needs to get done, and it's continuously adapting itself to the reality, because sometimes temperatures differ, sun doesn't shine, so it's a very dynamic environment that then forecasting becomes important. And In the discovery, pre-feasibility, feasibility, detailed design mode, that brain is using historical information, right? What the past was happening to come up with a plan, which is really the best way to design and plan for something. And you can also consider resiliency needs and so forth during that. But you're using historical information because nothing has been installed, nothing is running. So you can only look into the past or your assumptions and bring them in. But then that brain that designed it, we put in the driver's seat. And now it brings that whole body of knowledge from the design in, but it's that same optimization engine. So it's providing the optimal strategy every 3 to 5 minutes on a rolling forecast. And then the machine learning has learned about kind of the behavior and operational, what the load is going to look like. So then the AI is forecasting 48 hours what the load and what the production will look like. And then,
Yeah, fascinating.
And then what the strategy is. Do you want the best economic outcome? Do you need carbon reduction? Or, hey, there's a weather event coming. We need to prepare for resiliency.
Yeah, charge up now while the sun is shining.
Yeah, exactly.
Yeah.
So it goes into that mode and offers. So it's fairly autonomous, very seamless in the integration process. But we didn't see this out there. I mean, there's a lot of companies providing controls and different ways of controls, very large companies to small companies offering controllers. And there's companies that do some sort of planning. But we didn't see any that did planning and controls under the same platform. We felt that that was a huge gap that was driving a lot of the fear and uncertainty into these systems that we thought was an important problem to tackle, and tackle in a way that drove not only confidence but also customer adoption. And that meant that you had to have a way to communicate these benefits in non-technical terms. And that's why we built the interface that we did. Very much, you asked me what got me into this. I said video games. So we also tried to create a video game-like environment within the planning and the operations side, so that different stakeholders can, not only be attracted, but also have the curiosity and appreciation for what is being done and delivered on a minute-by-minute basis.
A little bit of gamification of our, our utility.
Yeah, it's got to look fun, and it's got to be accessible. Otherwise, why?
Right. Otherwise, we're back to spreadsheets.
And PhDs. How many? We want a lot of good, hardworking, smart people to be participating in the energy transition, and you can't have a PhD tool. We work with a lot of PhDs and researchers, and we make that, I would say, sophisticated environment available to them to really push the edges and boundaries of new technologies. Like, we have small modular nuclear reactor model within our system, and that came through work with researchers at Idaho National Labs. We work closely with Arizona State University, and they have a whole curriculum around our software as well. But that also, brings a diversity of thought leaders and engineers and designers and financiers together, and to be able to articulate the value and the benefits to each one of those different stakeholders. We felt that a visualized, animated environment that was highly graphical would be the most efficient way to communicate the benefits of these systems with the technical rigor, so that the confidence around the outcomes was also baked in for those folks that are in conversation and trying to make a decision on a project.
Yeah. I might take some heat for this, but I love a good GUI. It just makes all the difference for me.
It does. It does. That's what we touch and play with, day in and day out. And if it's a chore, then,
Yeah. Then we're back to spreadsheets.
Exactly.
Well, yeah. Microgrids. We've talked a bit about microgrids, but what are some key considerations for planning, implementing, and running microgrids that people maybe miss sometimes?
How important it is to size and choose the technologies as you're trying to solve the operational strategy as well. So I'll give you an example, Daniel. let's say you have a Honda Civic and I have the same exact Honda Civic. We bought it on the same day off the same assembly plant. So same exact machine. You're going to drive it like a Formula One driver, and I'm going to drive it like a retired person. We're going to get very different fuel economy, wear and tear, speed to how fast we're going to get to something, how many miles per gallon you're going to get, so how far you can go with the fuel you have versus how far I can go, and what the overall operating expenses are going to be. You know, you're probably going to be changing brake pads and tires more frequently than I am. Same exact machine, but two different brains driving it completely differently. And if we said, hey, our objective is to have the most fuel efficient, cost effective transportation vehicle, well, I can probably achieve that, and that's why I made the purchase decision. You went in thinking that, but you drive it very differently, and you're not getting the results that you thought you would get. So just putting solar panel and batteries and chargers and generators out there and saying this is the size you need because this is how much you consume isn't necessarily going to get you what you want. You have to be mindful of how these systems are going to get orchestrated together and how they're going to all work together as a single unit to achieve a certain outcome. And that means that the driver behind the wheel, to use that metaphor, is important in the planning as well. So if we had put Daniel, the Formula One driver, assumptions into what kind of vehicle we want, we would probably arrive at a different vehicle than me. So you might not be getting the Civic. I would be getting the Civic.
Fair enough.
But
Are there?
But that's missing.
Sure.
You know, I think that's really important. That's what we deliver on.
Yeah, it's how it gets used.
Yeah.
I have a strategy. I don't like to use my tools to 100% of their capability because that's where things break. I like to, give myself a little bit of overhead.
Absolutely. Margin of safety.
Yes. Yeah. And like repair time and maintenance. Anyway, I could talk about that all day. Have there been any mixes of technologies that customers have been surprised to get as an output or as a result for what they're trying to achieve?
Yes, in that, when you ask the algorithm to generate the optimal solution for you, the user can give as much flexibility or really reel it in so that the algorithm doesn't have a whole lot of room to make a decision. So by that, I mean, let's say you want to consider batteries. You can tell it, hey, consider it if it makes sense based on the goal that I'm going to give you. Or you can say, I want this size battery no matter what. Or at the very least, I want this size, and if more makes sense, build it for me. Or you can say, we already have this much batteries on site, and if more than that makes sense, design it for me. So you can give that level of flexibility from where the algorithm has complete freedom to plan what it wants to the constraints. When you give it that complete freedom, then you do arrive at some very interesting decisions, not just on what technology to pick, but how it's suggesting you operate it. Oh. Because, you might have an opinion on how that battery should charge and discharge based on your experience and so forth. But when you have an algorithm come up with it, it'll find opportunities and unique instances and nuances to leverage that, it's hard for us to calculate through all of the possibilities, variables, and interactions, especially given let's say you got solar panels, right? So you got the weather component, then you got the tariff and what the utility is going to charge you and demand response. And, you start stacking it all up and, you can come up with probably a strategy with a set of technologies that are good, but are they the best? And what I've seen is, the algorithm will omit a certain technology or select a certain technology quite vigorously. And then when I look at the operational strategy, why it's doing what it's doing, then it shows, I'm actually going to discharge the battery at these times and these other times. And I would have never, just thought on my own to do it the way that it's recommending it. But, it's achieving a superior outcome based on a set of variables and constraints that it was able to crunch through, millions or hundreds of thousands of equations that I just can't do.
Yeah.
And even with a spreadsheet, it would take me a very, very, very long time to go through all those iterations to get to it. So that's been, I would think, something that I always get surprised by once in a while.
Yeah.
Is it not only picks a certain set of technologies, but also it comes up with the operational strategy that is quite novel in some instances.
Have there been any customers or users that can you maybe describe a time where that happened to them and how they responded and kind of what it meant
Yeah,
to them?
it happens actually more. So early on, I mean, I myself, I'm guilty of this too. I came from a simulation world. So I had a previous company where we provided software for planning and simulation of electrical power systems. So very much a simulator driven person. And with Xendee, we decided to go with optimization. So with simulation, right, you can make changes, drive it, see how you did, make changes, drive it. It's great if you're trying to learn something. So like in an educational setting, because you can just move a knob, hit simulate, see what it did, move the knob again, hit simulate, and it does something. But with an optimization approach, it comes up with the best solution. You don't need to move any dials and knobs or anything. It's telling you this is it. And I went through all the stuff that you probably couldn't have even gone through with a simulator, and this is the solution I'm arriving at. So what happened in the early days is when you have people coming from a simulation background, they want to, well, what if I choose this versus that? And it's like, well, but that's not going to give you the best outcome. The best outcome that you have is what the algorithm is coming up with. So when they saw a strategy that didn't match their mental model of how it should work, the first reaction is one of curiosity. Why? So then we would explain to them the nuances of the optimization and why it's picking what it's doing, and then for them to run sensitivities where they can adjust certain factors, like maybe a cost factor or performance factor, to see why it's arriving at what it's doing and the level of confidence that it has in making the recommendation that it does. So it was initially more of a knowledge transfer and market education activity to get folks comfortable with the concept of optimization versus simulation. Sometimes the two, people can use the terms interchangeably, but they're fundamentally different math. And with one, you can play around and spend a lot of time and money and still not arrive at what you want, versus one that considers the whole problem space, crunches through all of it, and says, this is your best option here.
Yeah. Answers, not iteration, is kind of what boils that down.
Yeah, exactly. But but then you have to have confidence in what this black box is doing.
Right.
And we've done our best to not make it appear as a black box. So the engineering team has over 200 peer-reviewed research journals out there, lots of resources around the benefits of an optimization approach, and also the robustness of the math and algorithm that is coming up with the suggestions that it is.
When people see this, I have to imagine there are people whose whole job is to run these spreadsheets and manage these spreadsheets, and there's this tribal knowledge in different companies. When people see this, are they scared for their jobs or are they relieved?
Almost all are relieved. They're like, because think about it. If you have a manual process and you're the person everybody comes to, and let's say it takes you 2 days or maybe even 2 weeks to go through one project, and the business development team has given you 20 and they say they need an answer by Monday, that is not a happy place to be. So most don't have they're not wedded to the spreadsheet they created. They went and created that because before we were around, they went out trying to find something and they didn't like what was out there. So, they had to have a solution. So they went ahead and created it. But the benefit for us in that sort of environment is we now have a sophisticated user that understands the complexity, the challenges, and appreciates the clarity, the speed, and the sophistication that we bring. So they've already got the battle wounds of doing it the hard way, and we are able to demonstrate to them, you can actually do those 20 now in a day and have not only robust reporting, but a higher level of sophistication that you could have ever imagined having. So it's a pressure releaser for them in many, many ways. And then we also get a chance then to introduce them to the opportunity of bringing that same capability into their operations for the lifetime operation of the system as well. So now there are instances where, people have tried to build what we have built. And those are the ones where it's perhaps a little bit more touchy, where, they've spent many, many years and a lot of money. And then when we show up, where there's a commercial solution already
Sure.
available, then that's a different hurdle to overcome.
Yeah.
But I would say the majority have been suffering for so long that when we show up, I've seen physical reactions like, oh my God, I can't believe this.
Yeah.
And that's
wonderful.
what also is a signal to me, like, we're onto something pretty important and interesting as well. Because when people respond with the level of enthusiasm and the feedback that they give and the positiveness with which they interact with us, and they really want to partner with us and be a part of the journey and the team. So that speaks a lot. They see the technology, they see the team, and they don't view it as a transactional vendor interaction. They really want us to be very collaborative and working hand in hand with many of our customers and partners.
Well, we're about out of time, but we like to do a quick lightning round at the end, and I just have one question for you since we're a little tight on time. If you could wave a magic wand and change one thing about, power generation and utilities and infrastructure, what would it be?
It would be on the policy side
Oh.
to really open up the gates for commercial industry to be able to deploy on-site energy systems as efficiently and quickly as possible. So this is infrastructure and critical infrastructure. And for the energy transition to occur with the success, the speed, and the expectations that the public has, policy is going to be a key component. And having just one or two actors is not going to solve it. It needs to be opened up to the commercial sector, to the so that the financial industry can also start deploying capital and getting in front of many of these opportunities that are out there. So I would wave my hand around policy
magic
supporting commercial industry.
That's a good answer. I like that answer. One more for you. What gets you excited about the future of this? As you look out 10, 20, 50, or even 100 years, what are you really looking forward to seeing happen?
As I said at the very beginning, I'm inherently a person who loves technology, gets excited about advances in science. And what really is exciting for me is how much impact to how we live, the experiences that we have through our lifetimes, and the opportunities that will evolve as a result of the energy transition. So not just cleaner air, that's awesome. Cleaner water, that's awesome. Sustainability, beautiful. I love nature. I firmly believe in the need to protect the environment and to live in balance with the environment, but also the job opportunities that these new technologies bring in. So when we talk about microgrids, these are local on-site systems. You can't offshore that work. And these are good long-term jobs that engage all sorts of folks within a community, folks that love to work and repair, maintain things, to the analytics folks that like to crunch the numbers and optimize things, to having a environment in which your dependence on energy. I mean, the reality is we're becoming more and more intense users of energy. We're not shrinking in our needs for energy. We're increasing our needs for energy. So how can we do that in a way that protects where we live and ensures a future that is not only cleaner and more sustainable, but has really good jobs, has people that are proud of what they're doing, and they know that their jobs are secure and it can't be sent halfway across the world for someone else to do. So that workforce development opportunity gets me really excited about what we can do in this country to build the future workforce. And with it, also all the benefits around the electrification of transportation. I mean, everybody gets in a new some sort of electric vehicle, and they're just amazed with all the screens and all the connectivity options. And more our environment is becoming smarter, digitized in a way to improve the quality of life. And I'm just really excited about that. I mean, I grew up watching Star Trek, so at some point, it would be great to see. Some of those science fiction projections become science fact, and I feel that energy is at the centerpiece of all that. Because if you can solve carbon and energy, then a lot of those opportunities start presenting themselves. So that's what really gets me excited.
I understand you used to own the eepower.com domain, which is really funny because this event is eepower. Can you tell me about that?
I had eepower, I had eeship, and eeplant. So I still have eeship. I don't think I have eeplant anymore, but I used to have eepower because with my previous company, I always was thinking of maybe a blog or something,
or a virtual event.
But I just thought it was a cool domain name. So when I saw ePower, I'm like, you guys are awesome, because not only are you guys in the field and in the sector that I'm in, but I'm like, so that's where that domain ended up. So I'm glad it got used in a very important and successful way. So it just put a smile on my. I couldn't have imagined it. I'm like, what a small world.
Yeah, great minds. I guess.
Yeah, absolutely. So I love your name, and I love your company too. So
wonderful. I'd love to hear it. Well, Adib, thank you so much. This has been an absolute blast.
Absolutely. It was a pleasure as well. And thank you for this opportunity to share a little about what we do and our view into where the future holds opportunities for everyone.
Again, that was Adib Nasle, co-founder and CEO of Xendee. I always knew grids and distributed energy resources was complicated, but I really enjoyed running through that thought experiment and thinking through what it actually takes to keep these lights on. There are still 2 more live sessions today, one with advanced energy that will lay out the historical progression of power system architectures and the challenges we'll face in the future, and another session with Texas Instruments digging into microgrids and smart grids. So check those out. The next session is starting up really shortly here. And also make sure to check out the digital exhibitor booths. That's it for this session of EE Power Day, sponsored by Mauser Electronics. I'm Daniel Bogdanoff, and since this was the last keynote, you won't see me again today, but shout out to the Moore's Lobby podcast listeners. I'll see you over there for the next episode on May 7th. Thank you all for joining me today. I hope you enjoy these next 2 sessions.